Hey guys, it's Chris. Today we're looking over physics again, and today we're looking over 3 Newton's law and applied forces. So the first Newton law stated that an object stays what it is unless there's an outside force acting upon it. So what it's saying is, if you're just sitting there, right? Per se, you're just chilling. You will not change your motion unless you apply a force to yourself or there's an outside force applied to you, right? So you will just keep sitting there unless you want to stand up. So you will apply a pushing force to your body, and then your body will move up. Or per se, your mom hits you with like a baseball bat, right? So the baseball bat apply forces to you, and then you will move, right? But if there's no forces, you won't move. Same for a car, right? If a car is driving at a constant speed, v, right? The car will keep going at v unless per se there's like a wall that apply forces go against it, and then it will change its motion. So that's the first law. The second law is how we calculate forces. So it's said that the net force, F net, equals mass times acceleration. So this explains that if you have a car, right, and it's moving at a constant speed, so there's no acceleration, the net force on it will be 0. Because whatever mass you have, if your acceleration is 0, your net force will always be 0. And so let's say a car is moving at 5 kilometers per second, and it has acceleration of 1 meter per second, and it has a mass of 20 kilogram. The net force that's acting on it will be 20 kilograms times 1 meter per second. So the net force on it will be 20 Newton. This is very helpful when it gives you acceleration or velocity in a question that's asking you for forces. So always remember that your net force equals to mass times acceleration. And now to the third law. The third law is saying that for every action, there's an equal and opposite reaction. So per se, you are pushing a person, right, for fun, okay? You hate your friend. So this is Amy, and this is, let's call him Bad, okay? So Bad pushes Amy, right? So this means that Bad exerted a force on Amy. So for this force, there will be a opposite force. So Amy will exert the opposite force to Bad. So if they're both on an ice skating boot at an ice skater park, Bad will push Amy, so Amy will go forward. But similarly, Bad will go backward because he received an opposite force from the action. And now let's look at some questions. Now let's look at a simple problem. So it is saying that a 50 kilogram box is pulled with a force of 60 newtons at 30 degrees above horizontal, and the coefficient of kinetic friction is 0.20. So what you always want to do when you're doing applied forces problem is to draw a force diagram. What is a force diagram? Basically, you draw the object out, right? And then you label all the forces that is acting on it. In this case, there is a gravity force, right? Because everything is affected by gravity. And always remember that when there's a gravity, there's always a normal force that's opposing it to make it not fall into the ground, because there's a surface. And we have a force of 60 newtons at 30 degrees. And there is a friction going against it. Now we have our force diagram. We can label our X and Y forces. So our Y forces, Newton forces, plus the Y component of the force that we're applying equals to gravitational potential forces. That's because the block is staying on the surface, so vertically it didn't move. So the net force equals 0, and then the forces, so the going down forces should be the forces that's going up. So Newton force plus our y component of the forces equals to gravitational force. And on the horizontal line, we see our friction force, right? And the x component of our force. Again, according to the second Newton's law, the net force equals to mass times acceleration, and the acceleration is what we want to find. So now we know that we want to find the friction force. We want to, so friction force equals coefficient times normal force. So we have our coefficient, we just need to find our normal force. So our normal force equals gravitational force minus the y component of the force, right? So it will become 15 kg times 9.8 minus the y component of our forces, which should be 60 newtons times sine angle. Always remember the y component of a force is the sine times the angle of it times the angle that it gives you. So you'll get, let's see, 15 times 9.8 minus 60 times sine 30 should give us 117. So now we have our normal force. We can plug it in for the friction force, which should be 0.20 times 117, which should give us 23.4. So now we have our friction force. We just need to find the x component of the forces, which equals to 60 newtons times cosine 30, which is 60 times cosine 30, 51.96 Newton. So now we can plug all the data into the equation. It will be, oh, I write the equation wrong. Should be F minus friction force equals mass times acceleration, because friction force opposing the other force. So 57.96 minus 23.4 equals to mass times acceleration. So acceleration is 51 minus 23.4, 28.56 divided by 15 should be around 1.90, which is the closest to 1.87, so it's B. So to sum it all up, to do applied force problems, you need to do your force diagrams and derive an equation based on your force diagram. Always remember that. It is the basics of all problems. So you should always do a force diagram if it is mentioning about the net force. Thank you guys for watching, and stay tuned for tomorrow's.